Hi, I'm Jim Lombardo, your host for this YouTube channel. I know I've been away for quite a while and haven't made many videos in a long time, but I'm back now in 2022, and I'm excited to tell you that I have plans for a whole range of new Java and software development videos for your pleasure. And to thank you for being either a subscriber or just a regular viewer, I've got two new projects for you that I think you'll really enjoy that address the topic of encapsulation and cohesion, while also providing some useful utilities that'll help you in your own Java development work. So grab a beverage, get comfortable, sit back, and get ready to have some fun. The two projects are a project for measuring the speed of for loops, using various techniques from the original for loop prior to JDK5 and new modern stream and lambda techniques. While this isn't a highly scientific test, it does give you some interesting feedback about what kind of looping techniques are fastest and which one do you want to use in your next project. The second project is a PrettyFormat table generator. Now this is something that I have used in my own work for many years that produces nicely formatted tabular data wherever monospaced fonts are used. For example, typically in the console output. So a lot of times if you're developing an app, even if you have some kind of a GUI, whether it be standalone or web-based, it's nice to be able to test your code before you link it up with your GUI code. And oftentimes we use the console for that. But it can also be used for output to a GUI, for example, a JFrame panel or some kind of a text box where monospaced text is allowed as input. In any case, formatting monospaced columns can be very tricky because if you think about it, you've got different column justification, left or right. You've got spacing between columns that can vary. And then somehow you've got to get everything lined up just right. Well, that can be very difficult to do. This utility provides an automated way of doing that. And along the way, this project is useful for another very important reason. This project will also demonstrate the importance of encapsulation and cohesion in an object-oriented program. So both of these projects will be covered in this video, but we'll also make the projects available for you for download through my GitHub site. And the addresses for downloading these projects will be at the end of the video. Now, both projects are Maven-based projects. I actually developed these in the NetBeans IDE, but you can load these projects into any IDE that supports Maven. So, if you're ready to get started, we'll begin with the for loop speed test. Okay, so here we are in the for loop speed test project. Again, this is a project that I developed in NetBeans, but it's a Maven-based project, so it has a pom.xml file. And when you download this from GitHub by cloning it as a Git clone, you can run it with Maven using a plain text editor, or you can load it into any IDE that supports Maven. So before I explain how the class works, let's just see what it actually does. When you run this, it'll generate output that looks like this. And basically it goes through separate tests. So there's the enhanced for loop string test, the lambda for loop string test, the lambda stream loop, the original for loop, and so on. And we do this for strings, integers, and doubles. Now these are objects, not primitives. And what's surprising is that the enhanced for loop appears to be the slowest in all cases, and the original for loop is the fastest in most cases. Now that doesn't really surprise me, but it did surprise me that the enhanced for loop was dramatically slower than the stream or the lambda for loops. And that's just interesting. Now, I have to tell you that this isn't a very scientific test because all we're really doing is looping and getting a hash code as a unit of work. And we're looping over the same values over and over. In fact, what I do is I create 3 lists. I just populate them. I pre-populate them with 500,000 strings, integers, and doubles. And they're all the same. And so all we're doing is getting a hash code. But it's still interesting to see the looping performance differences. And I found this very helpful in my own work. Now, one caution, don't assume that just because something's faster, it's always better. Because, let's be honest, when you're looping through 500,000 items, the difference between, let's say, 9 seconds and 12 seconds is not the end of the world. And oftentimes, ease of use is more important than anything else. So, for example, either this stream technique or the for each on a list with a lambda, both of these are very convenient to use versus having to keep track of counters when you're using the original for loop. And sometimes you don't have you don't have access to the counters. A good example of that would be a set where you know. So the bottom line is I found this to be useful. So mainly what you're going to be doing is you're going to be looping over these collections. Now you can modify the size. You can go up or down. I think going much higher is useless. But going down surprisingly doesn't change the results much. They're a little bit faster, but the hierarchy of who's fastest and who's not is still the same. So hopefully you'll find this interesting. Hopefully it'll be useful in evaluating what types of for loops to use in your own work. And there you go. That's the for loop speed test. Hope you enjoy it. Okay, our next project is the PrettyFormatTableFormatter. This is a very useful utility project that I use, and I think you'll find useful as well whenever you're trying to output formatted text data, or I should say monospaced strings, to the console or any other place where monospaced fonts are used. And formatting tables can be difficult because you have things like left and right justification, different spacing between columns, and different links, string links for each line or each row. So to give you an example of what I'm talking about, let me run this. Now this project uses unit tests to execute the code so that you can see the results. So all you really need to do to view any of this is just go to the project. Let's set it as our main project first. Go to the project and just run the test. So you can see, just test the project. And it'll execute. There's several tests that are going to be run. There's eight tests as, in all. But here's what you get. Right here, you get this nicely formatted table. Now, notice that we have spacing between columns, but the spacing is based on the longest line in that column. So the spacing is consistent relative to the longest line. And that's tricky to do on your own. Also, we've right justified some columns and left justified others. And so getting this to happen in a repeatable fashion with varying criteria such as spacing between columns and varying justification per column can be tricky. So this utility simplifies all of that so that you don't have to think about it. And what I think is useful isn't just getting this output to happen, but actually what's even more useful is the coding techniques used. And we'll see examples of proper encapsulation. We'll see examples of modularization. We'll see examples of cohesion. And much of the design architecture guidelines will be covered in a follow-up video. In this video, we'll just cover the basics of how this works. In the next video, however, part 2, we will discuss those architecture issues: encapsulation, modularization, and cohesion. So let's get started. Let's look at the format of the project. There are 3 different packages. Actually, 2 different packages. We've got some general string utilities. These are things like getting the longest line, padding left and right. And then we've got the table formatter itself, which makes use of an enum for a left and right. And so the idea here is that this class is utility for outputting nicely formatted tabular string data where monospace fonts are used, such as at the console and with some GUI components. It primarily solves the problem of proper column justification where row length and justification needs vary. And the way this works is you input a 2-dimensional array of strings where the first dimension is the row data and the second dimension is the column data. So for example, you can see here in the Java comment, the first dimension, here we have our rows, and the second dimension is our columns. So all you need to do is create a 2-dimensional array of strings with your row and column data. That's the first input. The second input is the justify direction. You need 1 of those per column. So that is a 1-dimensional array. 1-dimensional meaning 1 justify direction for every column. So that has to line up with your whatever the length of your second dimension is for your input. And then the third input is the number of spacers. And so what you do is you say, I want X amount of spacers. Now the spacers are always spaces in this example. I guess technically they wouldn't have to be, but in this version of the project, spacers are fixed at spaces. So once you provide that input, first thing it does is it checks to make sure that you provided the right input. It throws exceptions if you didn't. Then it uses a string builder to build the strings for the rows and columns. And then it checks to see how many columns we have, loops through the columns. It applies some justification criteria, and then it adds the spacers, and then it joins everything together, and we get the output. Now there's some utility methods to left justify. These are columns of data, and to right justify. And these are columns of data. And in doing so, it calls the pad right and pad left general string utilities to do that. Yeah, so that's basically it. Now, I do have tests. So I have unit tests for all of the main methods. And you can run any of these individually, or you can run them all at once using the test suite, or you can just run the project tests. And that does the same thing as running all the tests in the suite. If you've never created unit tests or test suites, this is also useful in helping you understand how that stuff works. So again, if we run one of these, let's run the table formatter test. All you have to do is right-click on the file and say test file in NetBeans, and it runs the test for that file. And as you can see, everything passed. You can also just do a clean and build on the project, because Maven will automatically run your unit tests. And so as you can see, I'm cleaning and building, and look what happens. It runs the tests. And not only did it run the tests and it said everything passed, see, it ran all the tests, nothing failed, but it also runs the output. And so that's the table formatter project. I hope you find it useful. Now, one thing to be aware of, and this is relevant to the next video, part 2 of this series, and that is that I have, remember, this is a Git project. It's a Git-enabled project. And what I've done is I've created different branches. This happens to be the master branch, but there are other branches that, for example, there's a demo before I refactored everything and a demo after I refactored everything. And what's useful about this is when you watch the next video where I discuss object-oriented architectural features such as encapsulation, cohesion, and modularization, you'll see before the refactoring is done, some of those things are lacking. But after the refactoring is done, we solve all those issues. And it will be showing you how to refactor to improve encapsulation, cohesion, and modularity. And so I encourage you to watch the next video, part 2 of this series.